So here we're going to make micropipettes. So what we need to do is we need to decrease the diameter of our capillary so that we can deliver a very small quantity of the solvent. We want to have as small spots as we can. So when we light our torch, we need to examine the hood. We need to make sure that there's nothing that's flammable in the vicinity. Okay, and so what you're going to do is you're going to have both your hands on the top of the pasture pipette. And then as you heat it, you want to put the pipette right in the blue cone, and you're going to rotate it. Okay, make sure it's not a twisting action. If you twist it, okay, you'll seal the tube. And so as you rotate it so that it heats evenly on all the sides, you'll continue to do that until it's apparent that it's soft. And then in one motion, as you come out of the flame, you're going to stretch it out. Okay? And not everybody has to do this if you don't feel comfortable with it. There's enough micropipettes in one strand for about 3 or 4 or 5 people. For me personally, I like to keep the same micropipette that I use for all of my TLC spotting, and I'll just clean it in between with acetone. Okay, so that's all there is to that. Number one rule of pulling glass and working with glass is hot glass looks like cold glass. So be mindful of where your fingers are. Okay, I know it looks cool, but if you were to touch that, you get a nice little blister on your fingers. Okay, so most important thing, remember safety. Hot glass looks like cold glass. Okay, we're all done here. We'll close that off. And then we'll move back over here and begin with the experiment. Before I start on my thin layer chromatography, I'm going to have the column chromatography experiment all set and ready to go. To prepare my column, I'm going to have a ring stand, and these clamps will not close far enough to give you a good grip on the pasture pipette. So what I do is I just get a paper towel and I fold it up, and then I'm going to put it in between the clamp. So the first thing that you need to do is grab a very small portion of cotton. You don't want too big of a piece of cotton, otherwise it's going to take up the volume that you're going to want for your stationary phase. So then using the stem of a second pasture pipette, you'll gently pack that piece of cotton down into the mouth of the pasture pipette. And then you'll just shovel the lumina into the pipette, like in this manner. Try not to get it all over the place. And to about here. Okay, so that's as far as I'd fill the pasture pipette. And then place it into the clamp. Okay, and you want it to be nearly as vertical as you can get it. And so now this is all set for when I have a moment of downtime with the TLC. Okay, so then I'm going to move over to the TLC and begin on that part of the experiment. All right, so here we are with the thin layer chromatography. I happened to grab unknown number 51. There's more sample here than you're going to need. TLC is very sensitive, so I'll just grab a little beaker and put a few crystals inside this beaker. Set this aside. And then I'm going to add about 1 milliliter of acetone to it. Don't worry if it doesn't completely dissolve. Okay, and so there's my solution of my unknown. And here's my TLC plate. This particular plate is coated with silica gel. It flakes off very easily, so you want to be careful how you handle it. Don't get your fingers along the silica gel. Hold it to the sides. And using a pencil, about 1/4 of an inch up from the bottom, put a horizontal line. The important thing is to make sure that this line doesn't become submerged in the pool of solvent, your developing solvent. And just as we had talked about on the board, I partitioned that line into 5 different blocks. I have acetaminophen, aspirin, my unknown compound in the center, ibuprofen, and then caffeine. So what I'm going to do now is I'm going to spot at each of the crosshairs. So here's my micropipette that I prepared. And I use acetone to clean it out. And so then I'm just going to take a sample of my unknown. And very carefully, I'm going to spot right at the crosshair. I'm going to try and keep that spot as small as I can. I've spotted it twice, and that should be about enough for the concentration of my unknown. Okay, so I'll return that to the acetone. Okay, and then I'm going to go through with each of my standards, beginning with my acetaminophen. It's important that you don't contaminate these pipettes. Make sure that the pipette you drew from acetaminophen is returned to the bottle that says acetaminophen. Otherwise, we'll have contaminated standards. So just like we did with the unknown, I'll spot right at the crosshair. And I'll spot just once. And put the cap back on so the solvent doesn't evaporate out. Okay, then aspirin. Okay. Return it back to the test tube holder. Here's the ibuprofen. And last, we have the caffeine. Spotting right at the crosshair. Okay. So now I've spotted all of the crosshairs for my standards and my unknown. I need to check to make sure that I have sufficient amount of the standards and my unknown on the plate. So what I'm going to do now is I'm going to come over and I'm going to examine it underneath the UV lamp and make sure that I can see each one of the spots. All of these spots should be UV active. Okay, in the actual lab setting, the UV lamp will probably be in a remote lab or in a dark room so that you can visualize the spots better. The silica gel is treated with an indicator that shows the plate completely green except for where you have a component that's UV active. So as I look at my TLC plate, it looks like my unknown probably could use a little bit more sample. Okay, it's kind of faint. But if you're going to err, it's better to err on the side of not having enough on there. If you put too much sample on the plate, what you'll get is a streak. You won't have a clear spot. So I'm going to go back and I'm going to spot my unknown a couple more times to make it a little bit darker. Okay, so I've spotted a couple more times on the unknown. You want to make sure that you can see all of the spots having placed the plate underneath the UV lamp. If you can't see it initially with all the spots along the baseline, then it's a cinch that you won't see them after it's been developed. So it looks like we're good to go. So we'll move over and we'll prepare our developing chamber and develop our TLC plate. Back over to our TLC plate side and prepare our solvent. The solvent that we're going to use to develop this TLC plate is going to be 25% isopropyl alcohol hexane solution. And so we'll prepare 4 milliliters, so 3 milliliters of hexane and 1 milliliter of isopropyl alcohol. Okay, so place that in the developing chamber. Okay, so now using forceps, you're going to want to put your TLC plate in the solvent in such a manner that both corners touch the solvent at the same time. You want it to be as nearly vertical as you can get it without it tipping over. And so we'll just set it in here. Like so. And then we're going to cover it with a watch glass. And now we have a few minutes while this develops. So while this is developing, I'm going to come over here and prepare my solvent for the column chromatography. So I need 6 milliliters of the hexane, 5 milliliters of the 5% ethyl acetate hexane, and 10 milliliters of the 4% ethyl acetate hexane. I have a beaker, an Erlenmeyer flask, another Erlenmeyer flask as holding vessels for these solvents. So start with the least polar first. This is the hexane. So for the 5%, bring that to about 2.5 milliliters of ethyl acetate that I'll need for that. And then here's the ethyl acetate that I'll need. I'll put this in a second vessel here. And then for the 10%, I'll put 4.5 milliliters of hexane in my graduated cylinder. and 1/2 milliliter of ethyl acetate. Okay, so those are my 3 solvents that I'll need for the column chromatography all set up. It's a good general practice to come into lab having read through the experiment, having a good general idea for what you need to do. There's a lot of downtime, and so during that downtime you can get things together and ready to go for later steps. So coming back over here, looks like we have a little bit further to go with the TLC plate. So now we have some waiting time. So it's a lot about hurry and wait. Hurry and get something done, and then you wait for a few minutes for the next step. The TLC plate's been in the developing chamber, and now it's nearly about 1/4 of an inch from the top. So I'm going to pull it out. And you want to mark that solvent front. You can either etch it with the forceps, or you can use a pencil. Okay, and so the next step now is to examine it underneath the UV lamp. So we'll come back over here. So this is what my TLC plate looks like underneath the UV lamp. I did a good job in the solvent going up level. The spots are pretty much right above where the crosshairs are. But it looks like the acetaminophen was a little bit too concentrated. So I'm going to go through and I'm going to circle the spots. So here's the acetaminophen. As I determine the RF value for this, I would pick a center location, probably right about in here. Here's the aspirin. Here's my unknown, the ibuprofen, and the caffeine. So it looks like my unknown is ibuprofen, or Advil. Advil is essentially ibuprofen. But I'm going to now dip it into the bromocresol green acid-base indicator and just verify that conclusion. Here's the bromocresol green acid-base indicator. In your lab period, this will be back in the hood. So you just submerge your plate and then try to remove as much of the solvent as you can. Dry it on the plate. Okay, so you can see at the top, here's the ibuprofen, it's yellow. Generally, it's a little bit more pronounced than that. Maybe as it dries, it'll show up a little bit stronger. So that completes the identification of the unknown analgesic then. Okay, so the first step that we need to do here is we need to saturate our column with the hexane. So I'm just going to add hexane to the top of it. You can kind of see the difference in the contrast between the wet alumina and the dry alumina. You can kind of accelerate things along by using a pipette bulb, but the important thing is to remember here is after you've depressed it, remove it before you allow it to reinflate. Otherwise, you'll create a gap in your plate, in your the column. So I'm going to let the solvent drop down so that it's even with the alumina. And then I'm going to place 1 drop of spearmint oil directly on the top of that plate, or the column there. So once it's been saturated, I'm not going to let it go dry. So I'll begin my elution series. This was the hexane that I prepared prior. Okay, and now I'll start to collect my fractions. Set this aside. Okay, so while this is going, I'm going to go ahead and do this, make a standard for the, that'll be a reference throughout the experiment. So I'll grab about 1 milliliter of hexane. And there's still some spearmint oil in the pipette that I used to load the sample onto the column, so I'll just use that. Okay, so then grab a TLC plate, and I'll mark along the baseline like I did with the analgesic. Prepare my reference here. Spotting at the crosshair once again. And cleaning out my pipette in between. Okay, I need to prepare the solvent. So 10% ethyl acetate hexane, so that's 4.5 milliliters of hexane and 0.5 milliliters of ethyl acetate. That's my first fraction. And this will be my developing solvent. I'll use the same chamber that I used for the identification of the unknown analgesic. I poured that remainder of that solvent from the part A into the waste bottle for part A. Then using the forceps, I'll load this into the developing chamber. our reference TLC plate has been developed. Okay, usually we have TLC plates that are a little bit more narrow than this, just to cut down costs. Whereas this was just one component that we were measuring. It would have been better to have used a smaller TLC plate, but this is all that I had available at the moment. So looking at it underneath the UV lamp, okay, I see just the one spot, and I'll go ahead and circle that. That would be my carbone. Okay. Before I dip it in the Chromatography dip, let me just make sure this doesn't go dry on me. So the Chromatography, the potassium permanganate dip, works just like the bromocresol green dip worked. Just dip it in and try to touch off all of the solvent that adheres to it. Okay, so this is what the TLC plate looked like after developing in the Chromatography dip. Clearly the carbone shows up very strongly. If you look very close, there's a faint spot just below it that represents the dihydrocarbiol. And sometimes, depending on the brand of spearmint oil that we get, the spearmint oil is sometimes quite faint. You can see it just barely at the top. Okay, as far as the elution goes, I've made it through almost all the way through the 5% ethyl acetate hexane. And I'm nearly onto the last concentration of my elution. So far I've collected 4 fractions. This is my 5th. It'll vary depending on how your estimate is on that 2 to 3 milliliters. Usually it falls between 8 to 10 fractions. Okay, so I've completed all the solvent systems, all the elution solvent systems. And for me, I came out with 9 different fractions. And so I'm going to partition my TLC plate into 9 boxes. I'll just number it in the top corner. And now I'm going to explore the fractions by TLC, collecting a small amount from fraction 1. I'll spot box 1. And then I'll clean it out in between with acetone. And last one is 9. And so we need to examine it underneath UV lamp. Look for our carbone. Okay, so underneath the UV lamp, it looks like it starts to come out in fraction 4. Carbone does. And very strong in fraction 5. Okay, so let's dip it into the Chromatography dip now. looks like fraction 1 has the limonene. 7 or 4 and 5 have the carbone, and I'm not seeing any. I'll go ahead and go 4, 5, and 6 for the carbone. I see a little faint piece at 7, a little faint spot at 7. So for my final assessment, I'll go 1, 4, 5, 6, and 7 for determination of the purity. And 7 was very faint, and so I'll do 3 of it. Just trying to make it a little more concentrated. Hopefully we can see dihydrocarbiol here. And so now we'll use the same solvent system that we used to determine the reference. Once again, we're going to try and put it in there as evenly as we can. I decided to take it out a little bit early. The plate's a little bit tall. I think this is enough to tell whether we've been successful in our purification or not. We see spots at 4 and 5. Okay, and now I'm going to dip it into the Chromatography 4 dip. So once again, if we look really close, we see a little hint of the limonene in fraction 1. And then I don't see a lot in fraction 6, but in 7, there's a little spot here that's representative of the dihydrocarbiol. Okay, so it looks like our separation was successful in our purification of the carbone. So then, just a conclusion, I would record all of your data as soon as possible after the lab. If you wait a couple of days, this purple color that you'll see will be brown uniform all the way throughout, as the Chromatography 4 will be reduced by components in the air. So you want to record your data as soon as possible. And then just put the plates in a little baggie and staple them to your report when you hand them in on the due date. Okay, so that's a conclusion for our chromatography. Thin layer chromatography typically is used for analysis purposes. Column chromatography is used for purification of our components.